All right, welcome back to part 2. So let's have some fun with derivatives. All right, so we want to find the following derivatives at the given value of c. So of course here we are going to be using the product rule. So let's see here. I got this function x to the 1/2 and this 1 minus x to the 4th. When we take the derivative, f prime of x, remember, I'm going to take the first function, which again, I'm going to make this as x to the 1/2. So if you want to, remember, this is just x to the 1/2 times the derivative of the second, negative 4x cubed, plus, and now over here we're going to take the second function, 1 minus x to the 4th, times the derivative of the first. Remember, this is 1/2. Now if you want to, x to the 1/2 becomes 1/2 x to the negative 1/2, right? That becomes 1 over 2, and I can put that x to the 1/2 on bottom. You just scratch work up here. Just get that answer real quick. We want to find the value of the derivative at 1, so we plug in the 1 here. We're going to get, what's that? Square root of 1 is 1. Negative 4 times 1, 1 cubed is 1. Plus this becomes 1 minus 1 times 1 over 2 times 1 to the 1/2. It doesn't really matter. All of this, 1 minus 1 is just 0. That whole thing is just 0. And so what we're left with is just negative 4. And there is our slope. Very easy to do. Kind of fun to do as well. All right, number 2, this is the hard one. When we do product rule here, when we do our derivative, f prime of x, we're going to get the first, x squared, times the derivative of cosine, which is negative sine of x, plus the second, which is cosine of x, times the derivative of the first. Now we're not done, because now we've got the sine of x here. So the derivative of sine is just cosine of x, and there's our derivative. You have your product rule from the first two, and then you have your derivative of sine itself. Plugging in the 2 pi over 3, trigalicious. Squaring here, we get 4 pi squared over 9. Don't worry, it's ugly, but that's all right. Sine of 2 pi over 3, boom, there's pi over 3. Sine is root 3 over 2. Plus the cosine is just 1/2 times 2 times x, which is, this is my x value right there. X is 2 pi over 3. 2 pi over 3. And then plus the cosine again, which is just 1/2. Yeah. There's your answer. Don't simplify that quagmire there. All right. I know what you're all thinking. Mr. Warnow, man, these derivatives are pretty cool. But how's it going to help me with my tangent line? I'm so glad you asked. Let's write the equation of a tangent line. Now remember, there are 2 things we need. The first thing we need is a point. Now this is different. Here we give you the x value. We have to find the y value. So we got to plug in the 2 here. And this becomes 2 times 4 plus 2, which is 12. So the point we have is 2, 12. Next, we need the slope. Isn't that dope? Nope. Oh well, there was hope. When we take the derivative, now I'm going to use my product rule. I don't have to. It's going to be the first times the derivative of the second plus the second times the derivative of the first. Plug in the 2, f prime of 2, and we get 2 times 2 times 2 plus 4 plus 2 times 1. So what's that? 8 plus 6, or 14. There's our slope, right? Get our tangent line. Y minus 12 equals 14, x minus 2. And there we go. All right, let's get trigalicious with it. Now for trig functions, here's my warning. For trig functions, you see this 3 cosine? Keep those together. Keep the 3 with the cosine, and keep the sign separate. So there's f and there's g. When I want to find the point, that's pretty easy to do. F of 3 pi over 4, we're going to get 3. The cosine of 3 pi over 4, excuse me. You're going to be so mad at me. I'll go back up here. I know most of you probably caught this. I just realized the cosine of 2 pi over 3 is negative. So that should be a negative, and that should be a negative. Oops. I know I'm going to hear that in comments. All right, so here we go. The cosine of 3 pi over 4. Cosine is negative in quadrant 2, so this is negative root 2 over 2. Sine is positive, so positive root 2 over 2. So we're going to get 3 times negative 2 over 2, or just negative 3. So the point, 3 pi over 4, negative 3. Next, we have to get the slope. So we need the derivative. And like I said earlier, keep the cosine with the 3 with the cosine. So the derivative of f itself, 3 cosine of x, times the derivative of sine, which is cosine of x, so there we go. Plus, now we're going to take the second, which is sine of x, multiplied by the derivative of 3 cosines. That's negative 3 sine of x. It looks ugly, but we're going to plug in our 3 pi over 4 right now. To get your slope, 3. This is just going to be root 2 over 2 times root 2 over 2. Plus, this is root 2 over 2 times negative 3, and again, another root 2 over 2. So if you notice, these are all exactly the same. They're just opposites, so that's 0. So there's my slope. So I write my tangent line, y minus, or plus 3 equals 0, x minus 3 pi over 4. And it's at this point, students always ask, Mr. Warnow, do I need to put that there really? I don't even think about it. I just do it. All right, try number 3 real quick. Let's go and try this one. Ready? We need our point. So I'm going to plug in the negative 1. F of negative 1. And I'm just going to do some math here. That becomes 3 minus 2 times, this becomes 1 plus 3 plus 1. So what does that become? 5. So the point negative 1, comma 5. To get our slope, we need the derivative, f prime of x. And again, I'm going to use my product rule. So if this is f, this ours. Taking the derivative, plug in the 1, plug in the 1. Let me rewrite that again. F prime of negative 1 to get our slope. And what do we get here? This becomes 3 minus 2. This becomes negative 4 minus 3 plus, here we get 1 plus 3 plus 1. And this becomes negative 6. So I'm plugging negative 1 plus 2. All right, so let's go and clean this up a little bit. This is just 1 times negative 7 plus 5 times negative 4. So we get negative 7 minus 20, which is negative 27. And that's pretty steep. So our tangent line, y minus 5 equals negative 27, x plus 1. We change our sign, plus 1. And there's our tangent line. I hope you enjoyed this video as much as I did. I will see you all later. Have fun. Bye-bye.